In the fall, the math club and the science club are created. It's great. You have 400 daily visitors, and the visits are increasing at a rate of 25 daily visits per month. And the math club has currently less than 400, as 200 daily visits, and the visits are increasing at 50 daily visits per month. So if there are currently, okay, so then it's asking, let's look at the question first. Predict when the number of visits at the two sites will be the same. So right now the science club has more, but what's happening with the math club's number? It's going up faster. It's going up faster. So our goal is to write the equations for two lines, and then what? Plot them. So for two lines, graph them, and then find where they intersect. Okay, so what's our first step? Write the equations for the two lines. So does anybody want to tell me? Let's look at the science club here. There's two things we have to relate. What do we have to relate?
The daily visits.
So we know there's 400 daily visits.
And we have the increase of
25 visits per day. So we have number of visits. So number of visits. So we need to give these a name. So we have number of visits and time. We have number of visits and time based on time. In a certain number of days, you will figure out how many visits have been made to the particular site. Are we okay so far? So we need to label them. What do we want to call the number of visits? What label do we want to give that? X? Okay, sure. So let's call that one X. That's fine. And what are we going to call time? In general, it doesn't really matter. Could we switch the labels?
Yeah.
It doesn't matter. No, you can do it this way. That's fine. But in general, where do you like time being? On the x-axis. So let's make time on the x-axis, and we'll make the number of visits on the y-axis. So we have labeled our variable. So y is equal to total number of visits. And this equals number of what? Is it by months or by day? Per month. Okay, yeah. So number of months. Sorry. So 400 daily visits is where it starts. So what time is it? How much time is, if we're starting, how much time has passed? If we're starting, how much time has passed? 0 months. We're saying right now, at a time of zero, how many hits do they have? How many visits do they have? 400. And they are increasing at what rate? 25 per month. So what does this give us? A point and a slope. If you have a point and a slope, what could you use? So you could say minus what? 400 is equal to 25 times x minus 0. So what do we have here? Y is equal to 25x plus what? 5. So let me finish the sentence here. At time 0, at the beginning here, when you plug 0 in, what do you get out? Is that correct? Is that the system you want? Sure. And then every month, how many does it add? 25. Every month it adds 25. So this is our first equation right here. Now that we've gotten the first one, is the second one pretty straightforward? If that's the first one, anybody want to guess what this is? 50x what? 200. You could use the exact same methodology we used before, but what did we figure out? The rate of change is going right there, and the y-intercept is right there. So do you feel comfortable with these? Just the same idea. So let's do it with it. Let's figure out the y-intercept. When x is 0 on this one, what's y? We already know. When x is 0 on the first one, what's y? What? 400. Thank you for speaking up. Exactly. Okay, so then the question now becomes, when y is 0, you have to figure out what x is. So you have to finish this equation when y is 0. So 0 equals 25x plus. How do we solve that? I'm not sure how to solve that. Subtract 20. So x is equal to over. So x is equal to 16. 2 points right there. Absolutely. So let's do this thing. What's y?
200.
200. So we want to know what happened. Don't move. When y is 0, how do we figure out what x is? 0 is equal to 50x plus 200. So x is equal to negative 4. Negative 4. Yeah, exactly. So what do you do with those two sets of points? Okay, so now we have to graph both of these lines. We have line 1 has these two intercepts, and line 2 has these two intercepts. So let's carefully graph them. One thing that's great to be aware of is the scale. You'll notice that on the x-coordinates you have negative 16 and negative 4, but the y-coordinates go 400 to 200. So this is not going to be drawn with the same scale on each axis. So instead what I'm going to do is I'm going to say this is negative 1, negative 2, negative 3, negative 4. If I kept on going that way, actually, it would be a ways until I got to negative 16. So all I can do is just change this to negative 16, negative 4. I can almost count negative 8, negative 12 rather, negative 8, and negative 4. Now on the y-axis we went from 0 to at least to 400. So let's make it 200 right here and 400 right here. So if we plot these points, negative 16, 0, and 0, 400, we plot them, we end up with this line for line 1. And then for line 2 we want, let's get a different color, negative 4 and 0, 200, graph that looks like this. The line that looks like this is line 1. So we're looking to estimate this intersection point right there. That right there is the solution we are looking for. So now let's estimate it. So if we're looking for this solution, which is actually right there, I went back and edited this graph so it's a little bit more accurate. My original green line was wandering into space. This solution right here looks like it corresponds, remember this is 4 and this is 8, so it looks like it corresponds to 8, so x is equal to 8, and it corresponds here to y is equal to 600. So it looks like our projected solution is 8, 600, so that means 8 months, and they will have a total of 600 visitors. How can you check that? Well, let's go back to our original equations right here. Our original equations are right here. And we're going to test the solutions. X is equal to 8. And y is equal to, so look right hand side when we plug in 8 into each of these. 25 times 8 plus 400 is 200 plus 400, which is indeed 600, which is what we want. And then we plug x equals 8 into right here, and we end up with 50 times 8 plus 2.